Good morning. The video is the extra review, chapter 3 extra review sheet for Algebra 1. Problem number 1 says determine which of the values are part of the solution. So you have two choices. You can solve this and plug in this value and say yes or no, plug in this value and say yes or no, and plug in this value and say yes or no. So another choice is to plug in this value, and this value into this existing inequality. Then you can solve it from there. So I think I'm going to solve it. So I subtract 2, and I get 5x greater than negative 10, divide by 2, or divide by 5, and I get x greater than negative 2. So the question is, which one of these values are bigger than negative 2? Yes. Negative 1 is bigger than negative 2. No. Negative 3 is not bigger than negative 2. And yes, 4 is bigger than negative 2. So solve, then compare. Next problem says solve and graph the following inequalities. So we are going to start doing these. Don't forget to flip that inequality if you divide by a negative. Divide by negative on last step, because the dividing by negative flips the number across 0 on the number line. So you have to switch the inequality to make it true. So here I'm going to subtract the 10, so I get x less than or equal to negative 22. Now on the number line, negative 22 is here. Closer to 0 is negative 21. It's bigger. And then negative 23 is here. So I'll circle it, and I'm going to fill it in because it can equal, see? Less than or equal to negative 22 is to the left. So there's the graph. All right, in this problem here, I'm going to multiply by negative 10. That's really just the last step, see? Since I multiplied by negative 10, I get negative 50 over here. I've got to reverse this. And so, or I can say x is less than or equal to negative 50, because I just made it more comfortable. So here's negative 50, here's negative 49, a bigger number, and here's negative 51. So I'm going to circle it, fill it in. Less than or equal to negative 50 is to the left. All right, next problem says x divided by 2 minus 3 is negative 15. I'm going to add the 3. And I get x divided by 2 is greater than negative 12. Multiply by 2. Now it's a positive 2, so I don't flip this. The 2's cancel, and I get x is greater than negative 24. So here's negative 24, here's negative 23, and here's negative 25. I'm going to circle it, leave it open, because x cannot equal negative 24, but it's all the numbers greater than that. Stop the video and finish the problem if you need to. Number 5, you're going to add the 4 to both sides. And those cancel, and I have 24 on this side, less than negative 3x on this side. Now I can flip this around now if I want, so I can write negative 3x greater than 24, and then I can divide by negative 3, and I reverse this inequality. X less than negative 8 is what we get. And this is negative 8, here's negative 7. Here's negative 9. I'm going to circle negative 8 and graph to the left of negative 8 because this says x less than negative 8. All right, these are just more complicated multi-step inequalities, so they're not too bad, but we'll go through them. This problem says, it looks like I have to distribute to remove these two parentheses. 4x plus 4 is on the left, less than negative 2x minus 8 on the right. Now this is just like an equation, so I add the 2x, And I cancel those out. I have 6x here plus 4 less than negative 8. Subtract the 4, and I get 6x. Subtract that 4 there. Run out of room, but that's okay. 6x less than negative 12. Divide by 6. That's a positive 6, so I don't reverse this inequality here. Negative 2 is what I get. Here's negative 2, negative 1, and negative 3. Circle, do not fill in. Less than are all the numbers to the left of negative 2. X less than negative 2. All right, moving on to 7. There's an invisible 1 right here that we need to take care of when we use a distributive property. So I'm going to write negative 1x plus 3 greater than or equal to 4x plus 18. I can combine these two 9s. Subtracting the 4x, I get negative 5x, and then subtract the 3 here. So negative 5x greater than or equal to 15. Divide by negative 5. Oh boy, that's a negative. So x less than or equal to negative 3 is what I get for the solution. Let me put a box around that one too. Negative 3 is here. Negative 2, closer to 0, bigger number. Negative 4 is here. I'm going to put that point on negative 3, and all the x's less than or equal to negative 3 are to the left of negative 3. Okay, so it looks like we're going to be moving on to the compound inequalities now. And those are two inequalities. You can see them here and here, see? And then here and here. So when they're in between, that means less than a number and greater than another number. Your graphs are going to be sandwiched in between. They're going to be in between these two values. So we got to figure out what two values they are. So I'm going to add the 5, but I have to add it twice for these compound inequalities. And I get 3x is less than 18 over here and greater than 9 over here. Divide by 3 twice, and I get x less than 6 greater than 3 and greater than 3. So it looks like it's between 6 and 3. Here's 6. I can put 0 right here, I guess, but I'll put 3 here. I'll put 0 there. So I'm going to circle the 3 and circle the 6, and x is less than 6 and greater than 3. That means all of these numbers in between 3 and 6. There's a lot of them. That's the weird thing about math, but there's a lot of them there. All right, so the second compound inequality is 7x minus 3 on the inside after I simplify, less than or equal to 18, and greater than or equal to negative 24. All right, so I'm going to add the 3 to both sides. All right. And I get 7x less than or equal to 21, greater than or equal to negative 21. Divide by 7, and x less than or equal to 3, greater than or equal to negative 3. Well, that's not too bad of a graph. Here's negative 3. 0 is probably in the middle. And positive 3 is the same distance, so I'm going to circle both of those, fill both of those in, and fill in both, like that. So fill in between. X is less than or equal to 3 and greater than or equal to negative 3. Now, some of these are OR problems. So when you have OR problems, we have to look at pushing out the numbers, okay? Greater than, less than. So what that means is solving both of these. So these are like two separate inequalities that we have to solve both of them. And remember, since this is an OR problem, we look for that greater than the big one, less than the smaller one. So this one here, I'm going to get x less than or equal to 3. All right? And then this one here will be x or x greater than 4. Subtract the 1 and divide by 3. So let's think about that. Here's 0. All right? Here's 3, and here's 4. So greater than 4, which is pushed out this way, or less than or equal to 3, which is pushed out this way. So if it's an OR problem, it kind of pushes out to the sides. All right, so let's look for that here because this is an OR problem. So I'm going to multiply both sides by the reciprocal here. This one's a tough one, negative 3 over 2. and then multiply by negative 3 over 2. Now I multiplied by a negative c to solve this, so I have to flip it. Now when I multiply negative 12 times negative 3 over 2, that's 18, positive 18. And if I divide by positive 3, I get or x less than negative 5. Now it's kind of flipped around, but you have to read it. X greater than 18 or x less than negative 5. So here's 0 on the number line. 18 is over here, and then negative 5 would be sort of here. Okay? So greater than 18, which is to the right of 18, that's this one, or less than negative 5, which is to the left. So there's the graph. So these OR problems push out, see? All right, now, these absolute value equations, you're going to drop with these absolute value problems. All right, so you're going to drop, you're going to isolate, okay, drop bars, and then you're going to solve. Okay, so with the inequalities are a little different, but these are equations. So, oh, I know, the first one's no solutions. You're going to watch out for no solution. The absolute value of a number is always positive. Okay? So it's always positive. This one, the absolute value of some number, okay, depending on what x is negative. So this one's no solution. Okay? All right, I got to isolate first. So in this problem, I'm going to add 6. And remember, these have two solutions. So the absolute value of 2x minus 3 equals 18. Now, I have to apply the rule for absolute value. So 2x minus 3 equals 18, so it could be on the positive 18, or that number, 2x minus 3, depending on what x is, could also equal negative 18. That's how far away it is from 0, is 18 units. Here, x equals 7, or x equals negative 7.5. Now I'll solve the equation real quick so I could save some time. All right, so now the absolute value inequalities, the hardest part. The absolute value, with absolute value inequalities, what we have to do is remember if it's or and, if it's going to push out or if it's going to squeeze in. So we read it. The absolute value of 2x plus 1 is greater than 9. So this one is pushed out. Okay, so it's pushed out greater than 9, less than negative 9. So we have to apply that here. So we have to write 2x plus 1, drop the bars, greater than 9, or 2x plus 1, less than or equal to negative 9. This one's less than or equal, greater than or equal to. Okay, so we solve both of these and we get x greater than or equal to 4, or we're going to get x less than or equal to negative 5. So we graph it. Here's 0, and here's 4, and here's negative 5. X greater than or equal to 4. That's this number here. All right? Less than or equal to 5. That's I shouldn't say that number, but it's 4. It's all of these numbers that are greater than or equal to 4, or less than or equal to 5. Okay, so we have time for one more, but then I have to do these three problems on a separate video, okay, because I only have 15 minutes here. This one is less than, so it's going to be squeezed in, so it's 3w minus 2 less than 10 and greater than negative 10. So this is w less than 12, all right, after I add the 2, and then and greater than negative 12. So it's here and here, and I got to stop this video because I'm almost out of time, but it's sandwiched in between, squeezed in, okay? All right, that's that.